Strawberries are one of the most popular fruits today with huge sales, and the main production method is greenhouse farming. Therefore, the timely detection and treatment of strawberry growth have become a hot issue to ensure production. The normal leaves of strawberries are dark green and perform physiological functions of photosynthesis and respiration. Yellow leaves have lost the ability of photosynthesis, thus affecting the normal growth of the plants and need to be identified and removed in time. In addition, the excessive white flowers can lead to an unfair competition for limiting nutrients among the fruits on the same plant, which may also cause a reduced yield and early decline. Therefore, the ASABE Student Robotics Challenge focuses on strawberries and the aspects of robots designed by the team in the standard division to achieve a navigation function without guidelines, identify yellow leaves and the white flowers of strawberry plants, and transmit the results of each plant detection to the server program. After more than 4 months of effort, our robot went through several iterations, constantly improving its form, function, operating procedures, and technical supports. To reduce the impact of soil compaction, we use a crawler walking mechanism for better adaptation to the environment, and use infrared sensors to identify holders. But after debugging, the effective distance of infrared sensors was short and required an outreach mechanism, which was not simple enough. So we switched to a laser sensor with a larger range of action, which can be mounted inside the track to make the robot have a better adaptability to the site. After dozens of attempts, we settled a crane link-based extension mechanism for the camera lift and infrared sensors for tracking. The infrared sensors is placed in the forepart of the robot, receiving the signal from both sides for tracking. Due to the difficulty of arranging the servo and fixing mechanism, we switched to a rod group driven by lifting sliders, with the infrared sensors inside the track for protection. We adjusted the extension mechanism by adding 4 more connecting rods to avoid damaging the field, which also helped to provide a larger visual field. At the same time, because the dart holder absorbs laser at a very high rate, it is difficult for the laser sensor to receive an effective signal and stop. To adapt our solution to more situations and integrate similar functional modules, we integrated the recognition of the plant holders into the camera recognition module, and this allowed the multi-threaded processing. One thread for recognizing the holder and saving the image containing the information about the plants, and another thread for processing the image as the robot's advancing. In addition, the robot would stop at each plant for identification originally, and the rods would be prone to wobble. Based on this design, the robot can identify without stopping, which also reduces the robot's wobble and improves the overall speed and smoothness. We also designed an emergency brake switch and 2 LED breathing lights to signal white flowers and yellow leaves, so that when the white flowers and yellow leaves are identified, the corresponding color lights will shine to visually transmit the plant information. Since our design linkage mechanism looks similar to the letter Y when unfolded, and each member of our team has the letter Y in their name, we name it Mr. Y. Mr. Y uses the Raspberry Pi as the controller and processor, using the Raspberry Pi's multi-threaded processing power to improve efficiency. Manipulate the servo rotation so that the linkage extension drives the camera to the desired preset position. The stepper motor was under the drive circuit to drive the crawler forward. Mr. Y first locates the plant by finding the holder, and then gets to the center coordinates of the holder to make a suitable mask to reduce the interference for the subsequent recognition. The result will be saved to the hard disk of Raspberry Pi. Then another thread will read the image for leaf and white flower recognition. Binarize the image by color and area threshold. Count the leaves of each color in it, and store the number of corresponding color leaves. In particular, the result of the white threshold extraction from the previous session are reprocessed with filtering and area calculation. The graphical matching is added to obtain the recognition results of the white flowers. Finally, the stems are coated and used to check the identification results of white flowers and yellow leaves. Now let's show you Mr. Y with our heart and soul in it. For unidentified plants, we first consider them as healthy plants and transmit the number of yellow leaves and white flowers to the GUI program as 0, and then update the number of yellow leaves and white flowers if they are subsequently identified. As you can see from the GUI program, Mr. Y lives up to the expectations and completes all the tasks perfectly in 25 seconds. Moreover, our robot is capable of bilateral work and can also produce the same 100% correct recognition rate after randomly placing the plants. After the task is completed, we can see Mr. Y is waving farewell to us. The weight and pressure of Mr. Y are shown below, and the construction cost of Mr. Y is demonstrated in the following table. There is no doubt that the time we spent and the friendship we built is priceless. In addition, Mr. Y has versatile applications. Mr. Y has the ability of bilateral recognition and has good adaptability to various situations. On the one hand, the size and connection of the rods are adjustable, so that the camera is direct above the plant when unfolded, allowing the robot to achieve simultaneous recognition of plants with a different arrangement. On the other hand, the machine vision algorithm can be adjusted to recognize strawberry plants obliquely downward by adjusting the camera angle on the existing mechanical structure. To achieve the goal, we form a 5-member team. Captain Yiyuan Lin is mainly responsible for main program writing. Team member Yuliang Zhou is mainly responsible for main mechanism design. Team member Daoyuan for identification. Team member Xinyue for circuit welding. Team member Yilin Zhang for script writing. We also have 3 professional instructors. Dr. Zhou Ye, who is responsible for circuitry and control. Dr. Yonghua Yu for reimbursement. And Professor Yu Zhang for mechanical structure. At the end of the video, we would like to thank the organizer ASABE for giving us the precious opportunity to participate in the competition. We as students can contribute to the development of agriculture, collaborate on the development of a strawberry maintenance robot with good functionality and innovative features, and also promote our abilities in the process of robot development. We would like to thank Zhejiang University and the College of Biotechnology and Food for providing us with the platform and support to successfully develop the robots. We would like to thank all the teachers and seniors for their guidance and teaching during the debugging process, so that we can understand how to make a robot with a soul. Last but not least, I would like to thank all of my team members for our joint efforts of connecting the team and Mr. Y as a whole. May our friendship last forever. All the members of our team have gained an unforgettable memory in this competition. Let's promote agriculture together.